Well, everybody, my name is Jacob Honeycutt, and before I introduce our next speaker, I want to take a few minutes to share a story with you, and I'm going to apologize ahead of time if I get a little emotional, but let's see where this goes. All right. So, like some of you in this room today, 18 years ago, I too was a young teenager with an obsession with weather and an extreme ambition to be a TV meteorologist and to chase a tornado. I had a local meteorologist in Kansas City, where I'm from, that was my idol, who I watched every day at 5, 6, and 10 o'clock. Back before social media took over, 41 Action News in Kansas City had a thing called the Action Weather Blog. Like today's Facebook statuses, Gary Lezak would update the blog every day with his latest thoughts and give a full analysis of the new data coming in, or what Gary would say, new data. I would hit that refresh button probably about 67 times a minute when big storms were taking an aim on Kansas City to get Gary's latest thinking. But then I would get buried in all the comments with all the other bloggers and argue with any of those who dared to challenge Gary's forecast. I mean, after all, he was Kansas City's most accurate meteorologist by weather rate for over 10 years. The weather blog was one of the most viewed blogs in history and became a staple in Kansas City. And I was in the middle of it, and Gary decided one day that he was going to have an in-person blogger meeting where we could all go and meet the other bloggers and the weather team. And of course, I was there, front and center. After the meeting, I walked out into the parking lot and I saw one of the most obnoxious storm chasing vehicles I've ever seen in my life. His right over there. As a young teenager, I was so excited when Gary decided to give me his personal cell phone number. So, of course, when I see this vehicle who had a lot of great stickers on it, I texted Gary and I said, "Gary, whose car is that? I want those stickers." And he said, "His name is John Moon. I'll get you two connected." And he did. And anyway, all right. So I got John's number, and yes, I got the stickers. Throughout my high school years, I had the amazing privilege to intern under Gary. I got to work at the TV station multiple times a week, sometimes multiple times a week, and learned how to build those graphics for the newscast and learned so much about forecasting. I even got the chance to be on air and help with wall-to-wall severe weather coverage multiple times, which was pretty cool for a teenager in high school. And as the years went on, John and I became true best friends. We both had the same passion for weather and storm chasing, and for years we were inseparable and created a storm chasing team together. We both had Gary by our side, teaching and mentoring us along the way. After high school, Gary and the TV station blessed us with another amazing opportunity to become the on-air storm chasers for the station. For years, we were tasked with keeping Kansas City informed of what was happening during severe weather. We also got to do many public events with the weather team, and our popularity went up. Fast forward 18 years, I've had so much to be thankful for. John and I have been just extended to our 8th year contract with KSN News 3 and Next Star Media down in Wichita with our great friend, Chief Meteorologist Lisa Teachman. We've learned so much about weather and storm chasing. We've chased tornadoes all over the country together and made lifelong memories. We tell the same stories every time we're together. It's just as funny as the time that it happened and the 100 other times that we've told the same story. But this all happened because of one man. So Gary, I want to thank you for everything that you taught me, you taught us, for being our mentor, our friend, for cheering us on, giving us tough love when we needed it most, for every opportunity that you gave us, even when it meant putting your own neck on the line. But most of all, thank you for my best friend, my brother. To To all of you teenagers and young adults in the room today, if you have somebody out there that you admire and respect, reach out to them. Ask them to be your mentor. The worst thing that somebody will ever tell you is no. But then ask again and again, just in a different way, because you never really know how it may change your life. Up here with me also is Gerard Jabali, and he is a meteorologist who also worked under Gary at KSHB 41. And with his expert guidance, encouragement, unwavering positivity, and friendship, led him on to be the chief meteorologist for News Nation and now Fox 45 in Baltimore. The three of us here are all the sons that Gary never knew that he had, and now what we so lovingly call him our Godfather. So, ladies and gentlemen, it is my absolute honor to introduce you, the founder of Weather 2020, former KSHB 41 chief meteorologist, and my dear friend, Gary Lezak.
I didn't think I was going to cry. My goodness. Thank you, Jacob and John and Gerard. And my gosh, that was quite an introduction. Great to see everybody here today. I'm going to share a new technology with you. Some of you probably have heard about. A few of you have been following it for about 3 or 4 years. A few of you maybe even a couple of decades. But I want to get started here with a little video. So let's get this video started. So what I want to do is everyone in here say, Gary. Gary. No, not yet. Gary, when are we going to have tornadoes this year? Okay, wait just a second. You ready? 3, 2, 1. Gary, when are we going to have tornadoes this year? Okay, let's do that again. All together. Ready? 3, 2, 1. Gary, when are we going to have tornadoes this year? Okay, that's pretty good. I'm going to let you know right now. Okay. So, anyway, I guess we can put the presentation up, guys, if you want to. Let's get rolling. What I'm going to share with you right now is the weather pattern that sets up every fall and then repeats over and over again. So, guys, do you have the presentation ready? Or do I have to push the button? Aha. A second. Sponsored by Canon. We're waiting. I've got a whole presentation. 2 minutes? Okay, I got 2 minutes to ad lib, so I got to tell you a story. All right. So, very interesting. We just heard from Tony and the devastation of El Reno, the horrible tornado. That day, May 31st, 2013. 11 days before that was the last EF5 tornado that ever occurred in the last 12 years or so. 2013, the Moore, Oklahoma tornado was May 20th, 2013. So what you may not know is that about 9 months earlier, October the 28th, was Superstorm Sandy. The weather pattern that produced Superstorm Sandy in late October is directly related to the weather setup, the synoptic scale. Kids, that's big, broad, 2,000-foot scale, basically, 2,000-mile scale. The Superstorm Sandy setup is directly related to the El Reno tornado. So 9 months, 8 months, 10 months before, we already have the information, the data available to predict when these disasters may occur. If you go back to October 28th, 29th, the Superstorm Sandy, there was a tornado outbreak in the plains. 11 days before that, there was a tornado outbreak in the plains on October the 17th, 2012. That pattern repeated. It was a 53.5 day cycle that year. 53.5 times 4 is 214. And 214 days after Superstorm Sandy was May 31st. So what I'm going to share with you when my presentation comes up here within a few minutes is that possibility, that ability to predict the weather that far in advance. And it's not just tornadoes, it's hurricanes, it's snowstorms. What has happened here in Colorado? Have you noticed the mountains? There's hardly any snow on them. If you look to the southwest, by the way, it's 67 degrees outside right now, okay? We're all in here, but it's an amazing day. And tomorrow's going to be 67, so you can get outside again tomorrow. But if you look down to the southwest, you will see Mount Blue Sky. It's off to the southwest, used to be called Mount Evans. Mount Blue Sky almost has no snow on it. In Golden, Colorado, where I live now, we've had 17 inches of snow this winter. The average is 38 inches of snow by now, 40 inches. The ski resorts are losing millions of dollars. Salt Lake City, Utah, how much snow has fallen in Salt Lake City this season? Does anybody know? 0.1 inches, right. 0.1 inches of snow in Salt Lake City, and by now, what do they average? 35 inches of snow. So what is going on? The pattern that's set up last October and November is cycling, and it's producing this over and over again. Some people will say it's going to suddenly change. No, it is not. It's not going to suddenly change. So the pattern behind the storms, the atmosphere has a memory. I'm going to go over my history for a few minutes. But first of all, how many tornadoes have we had across the United States since October? So you have October, November, December, January, into the first 6 days of February. How many tornadoes has there been? Does anybody have any idea? I'll answer for you know, because I told you. 83. 83. I told him earlier this morning. 83 tornadoes since October. Last year, October, November, December, January to February 6th, there were 260. Before you get concerned, oh no, we're not going to have a great chase season. A couple of years ago, we had a very light fall for severe weather, and it ended up being very active. So just know there's potential for that. All right, what you're looking at here, that's me. Ever since I was 5 years old, all I ever wanted to do is tell people about the weather. That's me maybe when I was 7 or 8 years old. I was fascinated by weather ever since age 5. And I got inspired. Kids, you're getting inspired today, I'm sure, by some things. I got inspired by this TV meteorologist. His name was Dr. George Fishbeck. He would go on the air in the 1978 year, the Star Wars calendar here. In 1978, 79, it was a huge winter in Los Angeles, where I grew up in Southern California. I didn't know that the weather was boring there. I thought it was very exciting. Well, this year it absolutely was. All right, so, but he would show the upper level winds, the jet stream, the 500 millibar flow, and explain how these storm systems were coming in to Southern California. So I got fascinated, and in my Star Wars calendar, this is a pretty big screen here, isn't it? It's amazing. On January 9th, 1978, I wrote, "A very large storm is dropping rain, very heavy, consistently raining. 2 to 5 inches of rain, or 2.5 inches of rain possible." So that's on the 9th. All month long, And 10 inches of rain fell that month. Kids, I recommend getting a calendar and doing what I did and start keeping weather entries. I did this for so many years. So I even wrote my first long-range forecast. January, forecast, more rain than usual. I got it right. It's pretty amazing. So that's 1978. Now let's fast forward. I went to the University of Oklahoma, got my BS degree in meteorology. And then something amazing happened. I got to meet this man, Gary England, an icon, a pioneer in radar, in TV, in meteorology. I became his intern. And it was 1985, 86. I was his intern, and something amazing happened on January 28th, 1986. Well, a couple big things happened that day. The Space Shuttle Challenger disaster. 7 astronauts were killed. That morning, I was an intern. I was not working on TV yet, and I was just watching the TV. But that morning, before the disaster, Paul Bouchereau, a morning meteorologist, he was on thin ice at the TV station. He was basically, they were trying to find a reason to get him fired, believe it or not. And so that morning, he made a big mistake. He went in. We used to, nowadays you see on TV, you just see us at 7:25, 8:25 cut-ins during the Today Show or Good Morning America or CBS This Morning. You'll see us come on live, right? Well, back then you just saw a picture of the forecast, 75 degrees, and we would record it. So he pops into the recording, and Paul Bouchereau goes, "Good morning. I'm meteorologist Paul Bouchereau. This is a great morning across Oklahoma this morning. It's up. Boom." He lands the F-bomb, okay? And the audio guy says, "Hurry up, Paul, you're on in 30 seconds. So he thought he erased it. We had this bulk eraser. He thought he erased it. And he put it in, he thought he recorded it, races it to the audio guy. The national guy says, "Here's what's happening in your neck of the woods," or whatever. And then it comes on, "Good morning, this meteorologist Paul Bouchereau. It's up. Oh, boom." He gets fired that morning. I am working, I'm just watching the TV on the Space Shuttle Challenger disaster, and Gary England calls me. He calls me, he used to call me Lezak, okay? Not Lezak. For 40 years, he called me Lezak. But he calls me, he goes, "Lezak, did you hear what happened today?" I said, "No." I said, "Yeah, this is horrible." He goes, "Paul said on the air, and you got an interview at 2. So the next thing you know, I came in with my little tie I had on. I'm 23 years old, and Gary England's on the couch. I'm sitting here. The news director's right there. It's 1986, so he's smoking a pipe in his office. He's like, "Did you hear what happened today?" And I go, "Yeah." And he goes, "You start tomorrow, no pay." I looked up at Gary England. He's on the couch, and he just goes like this. And I said, this is when I started learning negotiating skills real early. I never had an agent. I've always negotiated my own contracts. And I said to the news director, I said, "Can't you pay me the lowest pay scale you have here?" And he says, "No, take it or leave it. I need to know right now." I looked over at Gary England, and he just shrugged his shoulders again. I said, "Okay, I'll take it." And the next morning, I got introduced as the new meteorologist on KWTV in Oklahoma City. So an amazing day, an amazing time, and that's how I got my career started. And it's very interesting. This is now AI generated, so that's a weird looking, that is my hair, okay? But it's interesting. In my first few months on the air, Gary England taught me radar. And the radar of the day, some of you might remember this, we had folding. So Doppler radar early on at 29 miles per hour, it would fold. All right. So then 30 miles per hour would be like a little fold with 1 mile per hour extra. But then if it folded twice, that's 58 miles per hour. If it folded again, it would be 87 miles per hour. And I'd already been learning about Gary England's style. Very aggressive, very competitive. We had to be first. When he would say priority 1, the station knew we were on the air as fast as possible within 1 minute sometimes. And so I was by myself in the morning, right after I started, maybe March, April, and there was, maybe it was even May, but we had a line of thunderstorms coming in from the southwest. It was in the morning. I was the morning meteorologist, and I was analyzing the radar, and I saw the fold once, the fold twice, the fold 3 times. I'm like, shoot, as Gary England taught me, that's like 87 miles per hour, 90 miles per hour. And so I'm analyzing, looking at the radar, and I'm thinking, oh my goodness, what could that be? Is that right? Then a phone call. I answer the phone. I said, weather, you see a tornado in the village in Oklahoma City? Okay, thank you very much. So I put the phone down, and Gary England taught me, you get 2 calls that are different from the same location telling you there's a tornado, then you can believe it. Otherwise, 1, maybe not. So then I'm just sitting there thinking, then right then, second call, I see a tornado. So I'm like, oh my gosh, okay, thank you very much. I hang up the phone, I go, priority 1, because I never did. I just heard Gary England do it. And boom, I was on the air within a minute doing my first tornado warning by myself. And, it was probably already, the tornado, I think, had already touched down, caused damage, and was already gone by that point. So Gary England, instrumental in getting my career started. A year later, 2 years later, I discovered something by experiencing the weather, observing the weather. Up on the top left, that's me. In 1987, in November, there was about a 1 to 2 inch snowstorm. Then, in the picture middle left, I have all my descriptions meteorologically what was going on. That's a snowstorm. A snowstorm that produced about 1 foot of snow. Remember, this is Oklahoma City that averages 8 inches of snow winter. A 1 foot snowstorm. That barbecue grill has about 1 foot on it. Bottom left, my CRX in front of my apartment, major ice storm. Same winter. Top right, that's the same barbecue grill. The same barbecue grill. But this time there was wind with the storm, and so it drifted, and it's still about a 1 foot snowstorm once again. Then I went to Lake Tahoe with my dad, and it's got more snow. I just love snow. And then bottom right, March, more snow in Oklahoma City. Why this winter? Why would there be 2 1 foot snowstorms, all these other major winter storms in a place that doesn't usually get that much? I was obsessed with these 500 millibar maps. 500 millibars happens to be halfway through the atmosphere in weight. The top of the atmosphere has no weight, kids, okay? Near the surface, the average pressure is 1,013.25 millibars, or 29.92 inches of mercury. Okay, that's the average pressure. So 500 millibars just happens to be right down the middle of the atmosphere. And I noticed that the storm in November and the storm in January, believe it or not, the 1 foot blizzard storm and that other storm, the pattern looked almost identical. And that's when I started developing my theory that maybe something bigger was going on. So we fast forward 40 years. And you can see the atmospheric jigsaw. Everyone else in this room likely uses some of these pieces. A few of you that are really big into forecasting, you got ENSO, which is El Nino, and La Nina. La Nina is the cooling of the tropical Pacific Ocean. El Nino is the warming of the tropical Pacific Ocean, and likely a big driver to maybe even this winter. Okay, there's been a weak La Nina that's now beginning to warm up. The MJO, the Madden-Julian oscillation, a lot of people know about that because there's 200 papers written. There's only one paper written on what I've discovered so far, but there will be 200 someday. Dr. Madden lives just 20 minutes from here. He's 87 years old, and he's working with me right now to prove the LRC quantifiably through equations, and it's fascinating. But the LRC is the centerpiece of the big atmospheric puzzle. It's the science of where and when and what is going to happen. Here's one of the oscillations, though. You see right here, the AO just dipped very low. Why did the East Coast just get blasted by these winter storms? Likely a result of the AO dipping deep negative, but the LRC tells us when it's going to return. And if you look right here on the bottom right, the AO dipped negative about 10 to 11 weeks ago in November. In November, it was just a strong cold front. Just recently, it was a 2-week Arctic blast that has not let up on the East Coast. So the AO influence this year has been significant. But the LRC is a centerpiece. When you have the AO dipping, Arctic air will blast south, storm systems get generated stronger, and that's what we just experienced. And so right now it's surging back up towards neutral at this moment. But the AO is just a factor. So let's look at last year's weather pattern. I want to analyze last year's weather pattern for you because then I'm going to show you something fascinating. Here is the 500 millibar flow, 18,000 feet up. All right. This is the 500 millibar flow, valid on October 11th. Every year, we can talk about it if you have some questions later. Why does it set up in the first week or two of October every year? But this is the beginning of last year's weather pattern, not this year's, but in 24-25 season. This upper level low is some energy that was forming off the West Coast on October 11th. Last year just happened to be about a 6-week cycle, 41 to 42 days. So watch. There it is again, a system off the West Coast on November 22nd, 42 days later. 42 days later, January 3rd. There it is again. All right? And this time, when this energy came in and combined with the pattern that was developing overall, Kansas City had a blizzard. We had 11 inches of snow last January the 5th. When Kansas City had the blizzard on January the 5th, there was a tornado outbreak in Mississippi and Louisiana. It was a small localized tornado outbreak, but it was still somewhat significant. But that happened in that cycle. 42 days later, watch this right here. There it is again, February the 13th. Right before your eyes, this is happening every single year. Every single year is different, though. And then and by the way, there was severe weather with that. Then, March 27th, there it is again. And I can show you the May, the June, July, August versions as well. There's some summer influences. But anyway, look at that real quick. Let me just go back. Just look at these features. It's the same. Gary England said, Lezak, I saw it. It's the same but different. Okay, and I've used that term ever since. That was like 2009, 2010 when he experienced the LRC. He only saw it that one winter when Oklahoma City had a big winter that year. But anyway, you can see it. There they are. This is just one snapshot in time. It's the entire weather pattern that is doing just that. So what does this mean? Well, look at this chart closely. Every bar you see there is a day that had tornadoes last year. And in the part of the weather pattern that cycled through towards Christmas to New Year's, every 6 weeks produced this. Early October, right when the pattern set up, major tornado outbreak. November 17th to 20th, a few tornadoes. 41, 42 days later, December 24th, tornadoes on Christmas Eve. December 28th, over 100 tornadoes occurred last year, 2 years ago now. February 5th to 7th, tornadoes. 41 days later, March 14th, 15th, 16th, major deadly tornado outbreak. Some of you probably saw some tornadoes that day, those days. Then it returned in April, June, July, and even August. Last year there were 9 cycles. All 9 cycles produced in this part of the pattern. On the January 5th blizzard, which was about 5 to 8 days later, 7 of the 9 cycles produced tornadoes. So we can identify the parts of the pattern that are going to produce tornadoes and predict when they're going to return at an accuracy clip in the last 5 years that is now near 90%. All right? It's not just tornadoes. Remember last year, 41, 42 cycle. It was cycling between 38 and 44 days last year. This year is much longer cycle. Hurricane Aaron became a Category 5 hurricane on August the 16th. 42 days later, Hurricane Humberto became a Category 5 hurricane exactly 42 days later. Not in the exact same spot, but it is not a coincidence. Not only that, there have been 44 Category 5 hurricanes in history recorded, 44 of them. Only 4 of those 44 hurricanes never made landfall. Aaron was one of them. It formed in the Atlantic, crossed and curved off the East Coast, thank goodness, because it was so strong, went west of Bermuda, and it never made landfall as a named storm. Humberto never made landfall. It's 4 of 44, and these are 2 of those 4. Just like Oklahoma City's 2 one-foot snowstorms, we have the hurricanes predictable and with results like that. So let's apply it to this year. As I said, I'm working with Dr. Madden on proving out the LRC. What you're looking at here is the heartbeat of the weather pattern. We have found the heartbeat of the weather pattern, the DNA of the atmosphere, the blueprint of what's going to happen the rest of this year. All right? So what you're looking at here at San Francisco, the red line is a measure of that 500 millibar flow. Okay, like the AO index, we have a LRC index that we call it. And this is a measure of that river there above us. So you can see the flow across when there's a dip, that's a storm system. And right here, on October 14th, California had a major storm. But it's supposed to be a weak La Nina. So all these forecasts that came out, and I saw a lot of them, dry in California. These forecasts are coming out in late October, November. Dry in California this winter. No, already we know that's wrong. And then what happens? This year is a 10 to 11 week cycle. And Christmas week, 5 to 10 more inches of rain in California. But that's just San Francisco. Let's go to Paris, France. The same thing. Paris, France. Cycle 1 in the red. Cycle 2 in the white. 2 big storms. I wasn't paying attention to Europe, all right? But this is what happened. They had a big storm. They called it Major Storm Benjamin. They had tornadoes, 133 mile per hour winds, major power outages. And then they called it Major Storm Goretti. It just happens to be about 70 to 75 days later. I have someone in Switzerland thinking about working with us right now. They've got the date down for when this is going to return in March, all right? It's going to. San Francisco, California. Look at California getting that storm with 5 to 10 inches of rain, October the 14th. Then it returned, and this was predicted. I didn't know what the cycle length was. I just knew in about the second half of December, they were going to get blasted again. They had 5 to 10 inches of rain and 6 more feet of snow in Lake Tahoe. So we made a prediction, and it's been out there. I publicized it. First 10 days of March, maybe the very last part of February, another major storm similar to these two. It's not 100% certain it's going to happen, but probably in that 80 to 90% certainty. But that's what we are able to do. So, as I get to this year's forecast for you, your storm chasers, by the way, I was never a very good storm chaser because I just loved weather so much. I didn't like going out into western Oklahoma and seeing a tornado. Okay, I grew up in Los Angeles. Maybe that's why I didn't really care. When I was a bad storm chaser. I even went storm chasing with Howie Bluestein once, but I couldn't wait to get back. Oh my gosh, the thunderstorms are heading towards Norman. I've got to get back. I got to see this thunderstorm. So I would literally be with storm chasers, and I was driving, and they couldn't stand it because I made us go back to Norman when we were about to see a tornado. So I wasn't very good, but I am very good at predicting when they're going to happen. So let's look at this weather pattern, October 27th. It's important because it produced not much. You can look at the bottom left there. This is the problem. This season has not produced many tornadoes. As I told you, 83 tornadoes so far this season. But that's a small little outbreak. And then this is the pattern that was setting up to create it. There was an upper level low across southeast Missouri, strong jet stream energy coming in to the Pacific Northwest. Fast forward 10 to 11 weeks later, here it comes again. Okay, and when that energy swings out, it produced that tornado outbreak. And then on January 8th, I was talking to Jeff Bertowski the other day. He goes, "Hey, Gary, there was a storm on January 8th." I'm like, "I know. There it is." This part of the pattern is going to return. So what we do at Weather 2020, we predict when that's going to happen. The Storm Prediction Center will show, level 1, level 2, 3, 4, 5 risk, right? You'll have a marginal risk, slight, enhanced, moderate, or high risk, right? So what we do is I put together something just like that. Here is the forecast for March 16th to March 25th. I know it's a 10-day window. It's a 10 to 11 week forecast, but there's multiple waves that may produce severe weather in this segment of the pattern that's going to cycle back through. So Wichita, I have right now in a level 1 or 2. And then level 2 or 3 risk will be around that. And then in the middle, maybe a moderate risk. It's March, so we'll see how it sets up. Could be dependent on the colder air or not, but that's a 45-day forecast. As I said, how accurate are these? About 90% in the last 5 years. Now, this pattern is going to return. So when it returns and cycles back through, here is a day 1 and 2 outlook. Right now, okay? Based on meteorology, not based on climatology. In climatology, oh boy, that's hard. You're going to predict a severe weather outbreak at the end of May in southeast Kansas and Missouri and Oklahoma. Yes, but I'm telling you when that's going to happen. Now, that's day 1 and 2, and then it'll be day 2, 3, or 4 as it shifts off to the south and east. If anything, maybe I'm too far south on this. It's late May, June. I might want to lift that a little farther north. But this is just one part of the pattern. So again, just so you see this again, there is the part of the pattern that was analyzed meteorologically, looking at the 500 millibar level, what happened at the surface, and the results from the Storm Prediction Center. So based on that, there's March 16th to 25th, May 25th to June 5th, and the day 2, 3, and 4. So as weak as this season has been so far, just know the day is coming. You're going to be out there in the field. You're going to see severe weather, and it's going to happen. But my goodness, so far this season, it's been fairly quiet. So I do have, here's my email. If you want to email me, if you're interested, Gary@weather2020.com. We put these severe weather outlooks out. I have a product that's out there as well, this one. But the best one, I think, if you just follow along at weather2020.substack.com, and we've got thousands of people now following, and we share this information with you and try to explain it. I try to explain it. I do a video every week, sometimes twice a week. So with that, that's my presentation. How about that? It's almost dinner time. This is the last presentation of the evening. So we have dinner, and I got my dogs here, Rainbow and Sunny. You've probably seen them. I don't know, but let me know do you have any questions? Any questions? We'll take a few minutes of questions.
All right, guys. I'm going to walk around with the mic, so raise your hand. We'll get these questions answered. We got about 20
a few
minutes
back here.
Gary, so.
All right, this thing working? Okay. How would the rapid expected transition to El Nino affect the patterns here or affect the cycle?
Very good question. How would the potential change right now from La Nina conditions to an El Nino or warming of the tropical Pacific Ocean affect this? So what's going to happen is, by the way, those CFS V2 models are not very good, okay? So the La Nina, this past week, we'll see what Monday comes in at, but it's still minus 0.8 right now. So minus 0.8. And so it's still La Nina conditions, but all indications are within the next 4 weeks, 5 weeks, 6 weeks, that there's going to be a transition to an El Nino condition. And next winter may be an El Nino. But what happens why do I put LRC as the centerpiece of the big atmospheric puzzle? Because the pattern isn't going to stop cycling regularly in the range it's in now. It can go through a La Nina to an El Nino shift. The pattern will still produce the storms on schedule, but there are influences that El Nino may start doing. In April and May, perhaps precipitation patterns will shift west a little bit. Maybe Colorado could get a benefit from a storm system. I just don't think it's going to be that big of an impact. But just know Enzo is just an influence. The pattern is not going to change until next October. Next question.
Based on, so say the last 10 years of storm activity from 2016 to 2026, what would you say the hot spot for severe weather would be this year?
Gosh, it's just such a hard question. I haven't really completed my full analysis yet. So The event I just showed you, that's going to be an Oklahoma, Kansas, Missouri centered event. There are, this year, 4 parts of the pattern so far. In that 70 to 77 day cycle, right now it's really close to 75 days. There are 4 parts in that 70 days or so that will produce severe weather. So I haven't, as soon as I complete that analysis, I'll probably have that done and I'll line up all of my predictions and then we'll put them into one hot spot region and we'll see where that is. But I don't have that answered yet. Something really amazing is going on out there. I don't know if it's the wheel of weather, but I think it's on that side. Okay, question.
Hi. Do you think this whole concept that you have developed will become mainstream in the next 5 years?
I hope so. Well, I've been bringing it to the market for a long time. And so will it be 5 years? Probably at about 5 years. So it's gonna take a while. Discoveries take a long time. All right. So if you really go back and look at the history of what I'm doing here, it stems back to 75 and 80 years ago. Jerome Namias was a famous meteorologist. He was the head of the long-range forecasting division for the Weather Bureau, that it was called back in the 1940s and 50s. And he wrote a paper called The Index Cycle. You can call that up. And he has about 200 other papers published. And so, but he said that by November, each fall, there's enough information to predict the weather for the following winter. Ding, ding, ding. That's one of, I came up with that on my own without even knowing that. That's one of the 4 core principles of the LRC. October, November, a unique weather pattern sets up. Then he said, for some reason or another, these anchor troughs and ridges set up. Ding, 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 ding. There's an anchor that I call them long-term long wave troughs and ridges. So now I call them anchor troughs and ridges. And one of those anchor ridges stretches from Texas across Colorado to southwest Montana. And that whole region's being impacted. That just means storm systems are weaker and less frequent near that zone. And then he also said that a cycle sets up each year. And what he didn't quite push over the top is that the entire cycle repeats over and over again until the next fall.
All right, guys, we got time for one more question.
One more question, then dinner.
We'll go right over here.
Have you tried putting your concept to like the historic 1974 super outbreak known as Terrible Tuesday or some event like that?
That's a great final question. Thank you for asking that question. Yes. If you go back and look at the big April 27th, 2011 day, the Joplin day of that same year, Tuscaloosa, Alabama, the horrific tornado outbreak that happened then. Go back that year's cycle, I can't remember offhand. I think it was close to 51 days that year. But you go, no matter what year you choose, figure out what the cycle length is, and you'll see evidence of that big super outbreak in other cycles. So Joplin tornado was May 22nd, 2011. Jeff Penner, my weather producer, he and I were doing a special for the spring forecast, trying to get specific forecasts for Kansas City. And by the way, you predict for one spot, you're not going to get it to be so accurate, okay? It's general regions. But yes, the answer to that question is it does happen every year, depending on what the cycle length is for the year. So the 1974 outbreak, we'd have to go study and see when severe weather happened. I've gone back and looked at all of that. So thank you very much. I'm ready for dinner. If you have any questions, contact me. Thanks for letting me share.